Assalamualaikum and hello. My name is Nadia binti Abi Rahman and my number is 82585334. For this introduction, our study focus on household energy consumption and its impact on household expenses, operation costs, and environmental sustainability. Energy usage is influenced by several factors, including the number of occupants in a house, the electrical appliances uses, and the surrounding ambient temperature. To analyze this factor, we use a dataset consisting of 350 observation. The purpose of this analysis is to identify pattern and determine the factor that significantly affect energy consumption. In addition, a 35% simple random sample was selected to ensure that the result obtained are reliable and unbiased. Finally, both descriptive and inferential statistical methods were applied to support data-driven decision making and provide meaningful insight from the study. Thank you.
Good morning, and my name is Adawi binti Sujaya. Today I will present 2.0 sampling and data selection. I used the AI Gemini to perform simple random sampling. I wrote the following instruction to the AI. Number 1, we needed to select 35%. Number 2, use simple random sampling. Number 3, set the random set number as 25,912. Number 4, make sure the selection is truly random and unbiased. And number 5, AI Gemini display the data and provide a code script to save the result in both CSV and XLSX file formats.
Assalamualaikum and good morning. My name is Nur Syamsila binti Muhammad Nur. My metric number is A25A5411. So today I would like to present to you the result of descriptive statistic analysis. So for the first variable is average temperature. From the analysis, the mean is 22.61 and the median is 22.81 and the mode is 29.37. Next, for the standard deviation is 7.140 and the variance value is 50.98. Although there is a variation in the data. Next, for the second variable is appliances use. For appliances use, the mean is 25.61 and the median is 26, while the value of the mode is 36.62 and the standard deviation here is 14.11 and variance is 199.0. The highest standard deviation show the greater variety in usage, but overall data centers around 25 to 36 minutes, as seen in the graph. Inferential statistic. The level of significance chosen for this study is A0.05. In statistical and business research, A0.05 significance level is widely accepted because it minimizes the probability of making a type error while still maintaining sufficient statistical power to detect significant difference in the population. 4.2 Using t-test. The independent sample t-test is used to determine whether there is a significant difference between the mean of two independent groups. In this study, an independent sample t-test was conducted to determine whether there is significant difference in energy consumption between weekdays and weekends. So this is the sample of the independent sample t-test result for energy consumption of freedom and a p-value of 0.827. Since the p-value is greater than 0.05, the null hypothesis failed to be rejected. The result indicate that there is no statistically significant difference in energy usage between weekdays and weekends. The day of the week does not have a significant effect of the average energy usage in the sample data set. The obtained t-value of 0.219 indicates that the difference between the average energy usage on weekends and weekdays is very small compared to the variation within the groups. This difference is not statistically significant. Test for equality of variance produce a p-value of 0.360, which is greater than the significance level of 0.05. The assumption of homogeneity of variance was satisfied and equal variance were assumed. The independent sample t-test produced a t-value of 0.219 with 349 degrees. 4.3 using analysis of variance. Analysis of variance ANOVA is used to determine whether there are significant differences between the means of three or more groups. In this study, ANOVA was conducted to determine whether there are significant differences in energy consumption across different building types. This is the analysis of variance ANOVA energy consumption. The significance value obtained from Leibniz test is 0.217, which is greater than 0.05. The assumption of homogeneity of variance is satisfied. The ANOVA test produced an F value of 67.52 with a significance value of less than 0.001. Since the p-value is smaller than 0.05, the null hypothesis was rejected. This indicates that there is a statistically significant difference in energy consumption among different building types.
Next, I will present the ANOVA analysis conduction to examine whether energy consumption differs across building types. Before performing the ANOVA Leibniz test was used to check the assumption of homogeneity of variance. For the building type analysis, the test production and a value of 1.535 and a p-value of 0.217. Since the p-value is greater than 0.05, the assumption of equal variance was satisfied. Similarly, for the day of week analysis, Leibniz test production and a value of 0.839 and a p-value of 0.39360, which also meets the assumption requirement. Next, a one-way ANOVA was conducted to compare average energy consumption among commercial, industrial, and residential buildings. The ANOVA result showed F is 2348 equals 67.52 with a p-value less than 0.001. Because the p-value is below 0.05, the null hypothesis will reject. This indicated that there are significant difference in mean energy consumption among the different building types. Therefore, building type is an important factor influencing energy using pattern. Next, I will discuss disruption statistic for the day of the week analysis. The results show the average energy consumption on weekdays was 4171 units, while the average consumption on weekend was 4148 units. The difference between the value is very small. The independent simple test production a t-value of 0.219 and a p-value of 0.827. Since the p-value is greater than 0.05, we fail to reject the null hypothesis. They indicated that there is no significant difference in energy consumption between weekdays and weekends. Therefore, the day of the week does not significantly influence energy use in these dates. Overall, the inferential analysis highlights an important contrast. Building types has a significant impact on energy consumption with a p-value less than 0.001, whereas the day of the week has significant effect with a p-value of 0.827. These findings suggest the energy management strategies should focus on improving efficiency in different building types, particularly industrial, and commercial buildings, rather than adjusting energy policy based on weekdays and weekends. Now I will present the independent simple test analysis by day of the week. The purpose of this test was to determine whether average energy consumption difference between weekday and weekends. The null hypothesis states that there is no significant difference in energy consumption between these two groups. The descriptive statistics show that the average energy consumption on weekdays was 4171 units, while on weekends it was 4148 units. This difference is very small. The test result production a t-value of 0.219 and a p-value of 0.827. Since the p-value is greater than the signification level of 0.05, we fail to reject the null hypothesis. Therefore, there is no significant difference in energy consumption between weekdays and weekends. Overall, the inferential analysis shows that building type has a significant impact on energy consumption with a p-value below 0.001, while the day of the week has no significant effect with a p-value of 0.827. These findings suggest that energy management efforts should focus on improving efficiency across different building types rather than adjusting strategies based on weekdays and weekends.
In conclusion, based on the descriptive and inferential statistical analysis conducted, the empirical findings indicate that the functions of a building is the dominant factor influencing the average level of energy consumption on both weekdays and weekends. However, the energy consumption patterns on industrial buildings remain relatively consistent over time. Various residential buildings exhibit more irregular consumption patterns, largely influenced by the domestic habits and daily activities of their occupants. Clearly, we can see that there is only a slight difference in energy consumption patterns between weekdays and weekends. This variation is relatively minor and is unlikely to have a substantial impact on the overall cost of energy usage. These findings indicates that the primary function or type of a building significantly influence its level of energy consumption, whether the building is classified as industrial, commercial, or residential. Each building category exhibit a statistically significant difference in its average energy consumptions when compared with the others, suggesting that building function plays a crucial role in determining electricity demand. Based on overall findings, it can be concluded that future energy management and sustainability strategies should place greater emphasis on reducing excessive energy consumption, particularly in building categories such as industrial facilities which require so significant amount of energy to support their operations. Next to more effective energy management practice and targeted energy management strategies should be given greater attention. So grid management authorities and energy policymakers should focus on implementing more sustainable green energy transition mechanism and exploring the adoption of an intelligent building automation system on a broader scale within the involved areas. Overall, this study not only demonstrates the importance of building classification in utility planning, but also provide a strong empirical foundation to support researchers and industry stakeholders in developing more effective and sustainable energy conservation strategies. These findings are expected to contribute to addressing future sustainability challenges and promoting more efficient energy management practice.